Hi, this is Mrs. Roble. This is Chapter 10, The Mole, Part 2. So we talked in the previous video about taking numbers of particles and converting them to moles, or taking moles of a substance and converting into number of particles. We've also talked about molar mass. Now we're going to talk about moles of a compound. So notice that with the moles of a compound, we're essentially looking at how many of each element is in that compound. So we can look at the chemical formula, and this chemical formula is going to tell us the amount of moles of each element. So for instance, we have two examples here. The first example, we have CCl2F2. So notice because there's a subscript of 1, there's only 1 mole of carbon atoms. But chlorine has a subscript of 2, so there has to be 2 moles of carbon atoms. And fluorine has a subscript of 2, so there has to be 2 moles of fluorine atoms in that compound. So every time you see a subscript, that essentially tells you the number of moles of that element in that compound. So please remember that the molar mass of the compound equals the molar mass of each element. So for H2O, we have 2 hydrogen. Therefore, we're going to take the atomic mass of hydrogen and multiply that by 2, and then add 1 mole of oxygen, and we'll just add the molar mass of that oxygen. So molar mass tells us that we follow the conservation of mass. Here is an extended version of that diagram that I showed you in the first video. The only difference is here, we're talking about this section. So we're looking at the moles of atoms or ions to moles of compounds. So notice that if you're going from moles of compounds to moles of atoms or ions, you're going to use this conversion factor. So notice that the mole of atom divided by the mole of the compound. And we'll practice this in class, so it'll be more familiar to you. But this is a really nice diagram that shows you how we tie everything together. Now I want to show you something different. In a previous chapter, we talked about percent composition or percent mass. It's the same thing. So when you do those kind of calculations, remember you take the mass of each element, and this time you're going to divide by the molar mass. So you're going to calculate the molar mass of the compound to give you the percent composition. And we'll practice that in class. Now, we can actually do mole ratios, and that's something that it's the ratio between, if we have H2O, you have 2 moles of hydrogen to 1 mole of water. And it's essentially a fraction, okay? And the reason why we want to do this is we eventually want to look at what we call empirical formula. So empirical formula is the molar mass, and we're going to do some problems where I give you a determined mass by a laboratory procedure, and you're going to see, is that empirical formula, is it multiplied by a factor n? So I would not worry about this because I will show you some more examples of it in class, and it'll be like, oh, I know what she's talking about. But I just want to show you that we can take molar mass and we can take mole ratio, and we can actually figure out what we call molecular formula. H2O would be considered molecular formula. Okay, this is actually the last small bit of the chapter here. We can actually calculate the amount of hydrate. Now, whenever you see the term hydrate, we're essentially looking at water. So hydrate is a water molecule, and we do have substances you're going to see in the lab that have a different color based on the amount of water that's attached to that molecule. So for instance, we could have sodium carbonate. Here we are using our ionic nomenclature, and we're attaching a decahydrate to it. So the deca is 10, and the H2O is hydrate. You will need to know for this chapter the prefixes. Shouldn't be a problem because you've obviously practiced that with other covalent compound names. So the only difference is instead you're going to be looking at water. So if you have 2 waters, it's di. If you have 7 waters, it's hepta. If you have 10, it's deca. Now, what does this mean? We do a process where we look at heating a substance, and we want to determine the amount of hydrate, the amount of water that's attached to that compound. So 1 water would be 1 mole. Now you're going to do a problem where you essentially look at the original compound, which we call the hydrate, and that hydrate contains the water. You're going to heat that compound. You're going to remove the water. And then when you remove the water, you have what was left, which is called anhydrous. So there's no more water attached to that compound. You're going to look at the difference between the hydrate and the anhydrous compound. And then you're going to look at the mole ratio. So we're going to practice determining how many water molecules are attached to a specific compound, and we're going to use the mole ratio to help us determine that.